Hey Sammy, so I saw your question here. So you're asking video explanation for this property here. For many random variables x, probability of mu minus the 2 standard deviation. So if x is between larger than mu minus 2 standard deviations, but is less than 2 plus 2 standard deviations, is approximately 0.95. What they're trying to describe here, this is for many random variables. What they're trying to say is, on average, what they know is that if I drew a diagram to illustrate a bell curve, right? So most things when you're measuring, there's a bell curve, just like your IQ test and weight and all that general population. You get an average, which they call the mu. So the average is what most people score, right? So hence why it's like, this is where most people should get. So like an IQ test would be like 100. Then what they say is that in an IQ test, you see you can get 101, you can get 102, you can get 103, and it goes on, right? The score on average is 100. But what they know is that when they work out the spread, which we call the standard deviation, okay, which takes into account residuals and all that. So the standard deviation is a measure of the width with respect to, you know, n and the number of trials and etc. Or you do that, but a standard deviation is the width. So in IQ test, as an example, the standard deviation is 15, meaning that from 100, one standard deviation across will give you 115, and one standard deviation backwards will give you 85. Okay, so that's one standard deviation in the negative direction. So what they're saying traditionally in data, I don't know if you've covered the 68, 95, and 99.7, but one standard deviation either side of the mean gives you an interval. Okay, so you're working between 85 to 115. That means they know approximately 68% of most starters will fall between one standard deviation from either side of the mean. Meaning that if it was an IQ test, 85 to 115, 68% of the population generally will fall between 85 and 115, 68% of them. Okay? Here, it's saying 2 standard deviations. So 2 standard deviations would mean that I'm now saying another interval. So another 15. So that in terms of IQ, you're now going down to 70 and then all the way up to 130. This now represents approximately, so if I took this interval, so IQ wise, if I'm going to say the interval is between 70 to 130, the population it should cover generally about 95%. That's what it's trying to say. And then 3 standard deviations, 99.7% of the population. Okay, so the standard deviation, this is more of an approximate measure. It's a property that is like general knowledge that 2 standard deviations from the mean on either side, that interval will cover 95% of the population. So that means, say, in our class right now, class of 25 students, if we got them to do an IQ test, 95% of them approximately will fall between 70 and 130. That's essentially what this is saying. Okay? Now you're using that property to then answer example 22, sorry. Example 22 says you've got a situation where you're selling a number of chocolate bars, right? So again, you've got a distribution. You sell a number of chocolate bars for any given month, and the following distribution, you can sell 100, you can sell 150, you can sell 200, you can sell 250, you can sell 300. Now the difference between this data, X, is this is what we call discrete, because you can't get 350, you don't sell 350, so it's only 300 or 400, right? Whereas the one I'm showing you over here is what we call a continuous data, where there are infinitely many points that people could score between 100 to 115. But the theory still applies in a similar sense that 95% of it will approximately still be between where the mean is minus 2 standard deviations and mean plus 2 standard deviations above. So I don't know what my current average selling of number of chocolates is, because I don't know how many I'm selling on average. It doesn't tell us, but we can calculate that. Then we also need to calculate, well, what is the standard deviation? What is the standard width? Okay, because then once we know the width or standard deviation, we can calculate 2 standard deviations to the left and right, And we know this should be approximately 95%, but we have to prove it. And we need to then use our chart to say, well, where's that interval